Alright, so hopefully you guys can hear me well and see the screen. Just doing the problem of the day, day 7. You can see that I actually started the function here, but that's all I've done. I haven't actually looked at or thought about this problem at all beyond that. Just did a test recording and, well, class started, so I'm starting it over now. And you'll notice it's actually quite late, but hopefully my neighbors don't complain I'm not talking very loud. So if it sounds like I'm talking quietly, that's the reason, but hopefully I'm audible. All right, that being said, problem of day 7. So given an array of integers, I assume that means that that's going to be passed in as an argument. Check to see if the array is already sorted or not. Return true or false. So it looks like the function takes an array of integers and returns true, we could just say boolean, something like that. All right. Focus on clear explanation solution. Sure. Once you solve it iteratively, try to solve it recursively or using functional programming. Might not do that. I don't want to make the recording too long, so I'll probably just solve it once and then talk about it and not do much more than that for the recording purposes anyway. I might practice it in recursive and functional ways outside of this recording. If you have time, write and walk through some test cases for your code. Sure. And what's the time complexity of your solution? All right, so that's pretty much it. It's just this. Takes an array of integers, returns a boolean on whether it's sorted or not. So I'm declaring the function here. I've already forgotten what this is called. Declarative function, maybe? I'll have to look at the notes or watch the video for today. So I can't remember what that is, unfortunately. So obviously that's going to be one of the minor criticisms of this video. All right. That being said, so with the array passed in, see if it is sorted. I mean, if we wanted to just keep it super easy here, then it would be return r equals r dot sort. I believe we can pass in a function ab. So what this is doing is I'm doing an ES6 function. So basically I'm comparing array to the sorted array, or I'm going to run the sort method on array, the passed in array, and compare it to just the array. So see if the sorted version is the same as not sorting at all. And in order to handle more than single digit numbers, we have to pass in a function. And that function is return a plus b, if I'm not mistaken. I might have remembered that wrong, and I don't exactly understand how that works, but that makes it so that the sort algorithm works for multi-digit numbers, not just single digit numbers. So let's just compare now and say console.log check sort. So now we're invoking the function and logging the result. Check sort, and we'll pass in an array, which let's pass in one that is sorted. So this should be true. So if we run this, we're getting true for everything, so that's obviously no good. So this now would go into debug mode, which is perfect. I'm glad it didn't work too easily. I'm going to start by removing this just to see if this part of the algorithm is wrong, because I'm doing that completely by guess. And at least the first two should now be correct, in other words, true and false. And I'm still getting nothing but true. Interesting. So how could we debug this? Obviously we can run it in Python tutor, but I'd rather just kind of r equals r dot sort. So let's separate this operation and console log it. So console.log r.sort, because we know what r is. So let's see what r.sort is. All right, and let's reduce this to 1 just so it's easier to read the output, and let's use a not sorted array like this. All right. So it does seem to sort correctly, at least 1 through 5. I guess the problem is that it's making a copy of the array. So actually, yeah, I think that might be it actually. I think it's making a copy of the array. But while I'm here, I also want to test to see if my algorithm is correct. So let's do this one should fail under the normal sort algorithm. No, it's successful. Well, that's because it's in order. Yeah, so actually we should test with one above it. Hope that made sense. Because of the number of digits, this might actually fail more than the other. I'm just going to do this, because I feel like that might make it more likely to fail. 11, 2, 31, 4, 5. Obviously, that's not sorted despite running sort. So you see my issue here. It only checks the first number. So another way I can kind of emphasize this is by doing not 4, but 21. Does some sort of weird sort algorithm. So yeah, the 2 gets prioritized and moved to the front, but the number of digits is not considered. In other words, the standard array.sort, what it does is it checks the first number in the number and prioritizes that in the sort. So you see 1s, then 2s, then 3s, then 5. And the second number is not considered until they're the same. Once they're the same, then the second number, if it exists, gets sorted afterwards. If both are the same, then it'll, so in other words, if both are 2-digit numbers, let's say this one is 23. Now what'll happen is the 23 will come after the 21, because it'll check the first digit, both will be 2, and therefore it would be considered the same, so they'll compare the second digit, and 3 would be larger than 1. And so it will result in 11, 21, 23, 31, and 5. Let's see if that's right. Yeah, so we understand not only that it doesn't work as we want it to, but exactly how it determines that undesirable behavior. So now let's try that correction here, and we'll see if it is a fix for that behavior. So technically, if this works correctly, it should start with 5, then go 11, 21, 23, 31. So everything is correct except for the 5. And now we still don't have desired sort behavior, although it is sorting in some sort of strange way. Maybe it was subtraction? Yeah, see, this is the problem with not understanding why. You know what? Let's find out. Oh, by the way, that is the desired behavior, so interesting. But let's take this opportunity to an MDN sort. Yeah, I don't use Google as my default search engine. Sue me. All right, so let's see exactly what it does. Well, we know what it does, but we don't understand this compare function part. So compare function, here's the explanation, and it's optional, obviously, because it works without one. Specifies a function that defines the sort order. If omitted, the array elements are converted to strings, then sorted according to each character's Unicode point value. All right, enough of that. So what we learned is that we can do this. So we will actually remove line 17 and undo this. Not only undo it, but, well, actually, yeah, let's just log it for now, because I still want to kind of understand what these data sets look like. So 5, 11, 21, 23, 31 is indeed sorted, and it's exactly Well, it's not what's past it, so it should be false. But we can also do this one. So let's do these two. That'll be a good test. So they should return the sorted versions of those arrays. And line 22 is already sorted. So it'll return exactly the same thing, 11, 22, 31, 40, and 59. However, this one is sorted correctly as we would want it to be sorted because of this algorithm right here. I'll figure out the sort algorithm a little bit more off camera. But definitely, you know what? Let me note it. Sort algorithm detail. So that's another thing I'm going to study and understand. That being said, these are correctly sorting, so now all I have to do is return r equals r.sort. And the other reason that I think this is failing, you'll notice my linter or whatever is catching that extra parens. Very useful. True. Now one of them should be false. So I'm going to focus on the one that should fail. And what I'm going to do is console log r, and then console log r.sort a, b, a minus b. Is that right? Yep, that should work. There's an extra parens because of the console log. So, in fact, let's even do, so this one is sorted. Make sure it's a string. And this one is unsorted. So let's see how those look. Yeah. So it's saying, is this array the same as this array? And it's true? So I'm wondering if this array is mutating the existing array. Either way, I feel like we can make this work by simply storing that. So let's do const sorted equals r.sort a, b, a minus b. So this now is a different newly created copy array. So instead of doing this, we're going to do sorted. So now, if we compare this, we should get the correct answers. In other words, this should return false. Let's see. Still returns true. Baffling. Absolutely baffling. Like, I honestly have no idea what's going on here now. But I also want to try a softer equal statement, which shouldn't make any difference because the answer is true. Softer equals would increases the chances of it being true, not false, because it relaxes the constraints. So, what else can we try? Well, let's first of all make sure that looks the way we think it does. Unsorted, that's just a marker, that second string. So we know that when we see the output in the console, whatever has that string next to it is, you know, we can associate it. So, sorted. They look identical. Wait, what? R being passed in is sorted? No, it's not. Why is it suddenly sorted? Huh. R becomes sorted? Okay, I think we're drawing closer here. Pre-sort command. We're seeing what it is before we run the sort line on 17. Oh, so when you do r.sort, r becomes sorted. So that's the problem here. When we do that, we immediately make everything sorted. So r mutates, the sort method mutates the array that's passed in. Oh, that it's run on, since it's a method. So what we have to do is create a copy of array. So const r copy r equals r. So now we have a copy of r. And because it's an array, even though the array itself can't be modified, the contents of the array can be modified. So, and because it's good programming practice, we will sort not the passed-in array, but the copied array. So we'll do return copy r dot sort, pass in the a and the b, and arrow function it to a minus b. All right. And sorry, I need to compare it to r. So all those lines went gray because it'll never reach the return statement. Will catch everything. But I'm still going to comment them out just to be absolutely certain. And we're still getting true. How? Okay, so I'm going to do this. You know what? Let's just move these up. All right, so I don't think we have the sorted variable here, so this will fail. Actually, the bottom one will fail. Well, that one will copy r unsorted. Oh my goodness. And sorted. What do they look like? This is not a copy of the array. That's, I think, what's happening here. The arrays just point to the same place in memory. And so when I make the copy, it's actually the exact same thing and it's still modifying in the exact same way. This is actually really tricky. So I know what's going on. I just need to create a completely new array and then assign the values inside array to it, rather than actually point it to array. So what we can do is, this might not be the best way, but I just want to get a working solution. So const copy array, so that's creating an array. I'll make it an empty array. And then we'll run a for loop. Let's do for of loop. I'm a little lazy and I like the for loop. So const num of r. So what the for loop is doing is, because it's a for of loop, it's using r as the length of times it'll, loop, and each num is this const num is each element in whatever I'm looping through the array. So it'll be first, in this example, 11, then 23, then 31, then 21, then 5. And we'll just push them in. So copy r.push num. And now copy r is actually a copy of the array and not pointing at the exact same thing. So now if we run the console log, well, first of all, this should now produce false, because they're now not equal arrays, the same array. So the sort will only activate on copy array and not on the original r. So when they're compared, they'll be different and they'll produce false. False. Unsorted and sorted are the same because the sort command is not run on it yet, but they're still not the same array anymore. They're different arrays. And we can prove that by running an additional command here. Console.log copy r. So this should be false, meaning they're different arrays. So we should get a false at the bottom, we should get a false, and then a second false. In fact, let's even pre-test. We'll call it pre-test, so that we know which one is the pre-test, and that should be false. Yeah, and it's false, because they're not the same array. So we finally got it working, and now we can clean this up, remove all the console logs. So now we know we understand it correctly. And there you go. There is a working solution. So we'll just uncomment all these, and we should get true, false, false, true, true. Great. It doesn't work. Oh man. All right. Now everything is false. So I think the difference here is everything is false because they're not the exact same array. So what we need to do here is do a soft equals, because we only need to compare that the arrays contain the same values, not that they're identical arrays. And still false. My goodness. I'm going to go back a few steps of code because I am baffled. Absolutely baffled, because this is absolutely a new array, and we're pushing in each value of that array. So if we run this unsorted, sorted, and pre-test. Oh yeah, because so just to kind of separate it out even more here, let's do r.sort a b a minus b. So by doing this, maybe it's because we still don't understand the sort method perfectly. It's possible, and there might be something in there that is causing all this craziness. So unsorted and sorted. And obviously they look completely different because this should be false, but let's take one that should be true, such as this one. So now we're trying to get a true result, and we're going to get false, but why? They look exactly the same to me. Let's take out an equals. Okay, there must be something wrong about my understanding of this array. So one thing we can do is just compare every value inside the array. If that's what it takes to get this to work, I'm going to do it. So that means I'll have to run another for loop. All right, so this will just make the array sorted. I'll do it on the copy array though. So copy r. And let's work with something that looks different when sorted. So this, I can't believe how much trouble I'm having on this problem. It's deceptively difficult. All right. So obviously they're different. Unsorted, sorted, so those variables are reversed, but that's okay. Or those strings are reversed, sorry, meaning they don't represent what they actually are. So now, yep, this one is clearly the sorted version and clearly the unsorted version. So this is obviously not ideal, but what we can do is for, wow, how did I type that in that order? For const of, let's do copy R. That part doesn't really matter, it's just that they'll be tested in the same order, so we have to do... Actually, let's use a full for loop because we need more control of the index and such. We could also use for each, I believe. There's a way to extract index value, but just for... I'm more comfortable with traditional for loops, so we're removing one potential question area. Let I equals 0, very traditional. For loop I is less than copy R dot length. This part doesn't matter because they'll both be the same length. And actually we could do map here. I just realized. Yeah, we could definitely do map. But again, we want to compare it to the same index value in this second array. So yeah, let's stick to the for loop just because to eliminate one more point of confusion. I plus equals 1 because Ryan said it is, in very rare cases, better, more clear what it's doing instead of plus plus. All right, and what needs to happen here is copy R at I should be strict equals to R at I. And this should be an if statement. If so, if it's true, then keep going. Which means, I mean, that code is no use to us. We don't need to know. We need to know when this is false. So if the entire statement is false, I'm going to put parens on it just to be safe here. So if the entire statement is false, return false. Because if any position doesn't match, basically what we're comparing is check to see if the array is already sorted. So, and we're checking that by seeing if the sorted version of the array is identical at each position to the passed in array. So this is unmodified array, and we're checking to see that it's equal at each position to the copy. If it is, it's true. They are the same. And therefore, they are already sorted. If it's not true, we need to return false. So if at any point it is not the case that these are equal to each other. So this statement is comparing, are they equal? And this is saying, is that not the case? So if this is false, return false, meaning if they don't match. So if 5 and 11 are different, which they are, then it'll return false. That's kind of how it works. I made it way more complicated than it needed to be, but point is, the if statement runs the code after it if it's true. So if this is true, it'll return false, which is exactly the opposite of what we want it to do. We want it to be if this is false, then return false, because we want to say when it doesn't match. So we're saying 5 and 11 are equal to each other. And if that's false, then we want it to run this code, which is return false. That's what this does. Otherwise, this code would run when this was true. And so it would return false when they're equal, which is not what we want. So we run that code when it's not equal by reversing it with this bang. And so the logic is sound. It will return false when something doesn't match, because if any position they don't match, then that means it wasn't sorted, because the correctly sorted array and the unsorted array should match if the array was sorted to begin with. That was an extremely lengthy explanation, but I think it's clear in my head, and I'll just have to re-explain it. If I were to be explaining it to someone, I would first of all practice the problem and understand all the logic behind why I had so much trouble. But the point is, now I think I understand it, and all I have to do is return that false if it is false, and otherwise return true. I'm going to test it with that, which should return false, which it does, and then test it with everything. So now I am not only making sure I create a copy of the array by pushing in each element from the original array there, but I'm also checking each position to each individual array at a strict equals. And if any of them don't match, return false. Otherwise, if it is, goes through all these and never hits the return false statement, then return true. So what I should be getting, I'm going to, just for the purpose of the testing, comment out the console log so it looks a little bit less cluttered. We should get true, false, false, true, true. And we finally have it.